Hello students, in the continuation topic, we will learn about microwave filters. As we know that an RF signal could consist of the desired signal frequencies and the unwanted frequencies called the noise. How to categorize these filters? Low pass filter, high pass filter, band pass filter and band stop filter, which we have already so many times come across. However, each category, the filter is further divided into active and passive filters. The diagram very clearly depicts, we have the frequencies F1 and F2. It passes only the low frequency, whereas it rejects the higher frequency. When you go for the high pass filter, the reverse case, you have the input frequencies F1 and F2. It rejects the lower frequency, it passes the higher frequency range, that is why high pass filter. Similarly, we can speak about the band pass filter with frequencies of F1, F2, F3. It passes a particular band between F1 and F3, that is F2. That is by band pass filter. And band stop filter, it stops the particular band of frequency. For example, say F2 passes the other frequencies. This is how they are categorized as. Now we will just see the parameters related to the filters. Pass bandwidth or 3 dB bandwidth, stop band attenuation, the input and the output impedances corresponding to the filter, the return loss of the filter, the insertion loss of the filter, the overall group delay and the quality factor. Now what are the design methods used for the filter? There are two methods in general used. One is image parameter method, other one is insertion loss method. In early stages, image parameter method was used for low frequency filters in radio and telephony. But nowadays we prefer only the insertion loss method. It is resulting in a power loss ratio of PLR, which is defined as a ratio between the power available from the source network to the power delivered to the load. We have a lossless two-port network with the source connected, so the available power, the incident power and the load power. So you have the reflection coefficient also defined with respect to the input section. There is the source impedance and the load impedance. Now the same analysis could be spoken in terms of PLR equal to PA by P load, which is P0 divided by P0 into 1 minus of rho omega the whole square. If both load and source ports are matched, then we say PLR is equal to S21 square in terms of S parameter. Because A is the incident wave, B is the reflected wave with respect to port 1, and A is the incident wave and B is the reflected wave with respect to port 2. As rho of omega square is an even function of omega, we can say that it's a polynomial in terms of omega square. Then how do we write the equation? We write the equation as rho of omega square is equal to m of omega square divided by m of omega square plus n of omega square. This also already you would have learnt in DSP. So I can rewrite this equation as real polynomials 1 plus of m by m. So 1 plus m divided by n. So 1 plus m of omega square by n of omega square. So based on this above equation, the low pass filters are further classified into different types. The types are, as we know, it is maximally flat or Butterworth or binomial filter, equal ripple filter or the Chebyshev filter also called as, and the elliptic filter and the linear phase filter. All these are the various responses based on it. Now we have the general procedure for designing the low pass filter using the insertion loss method. The three steps involved are the filter specification, design a low pass prototype circuit, a model circuit, scale and conversion. In case of filter specification, it includes the cutoff frequency, stop band attenuation, pass band insertion loss and the pass band behavior. But in case of low pass prototype circuit, we are setting R equal to 1 ohms and omega C equal to 1 radian per second. Omega the angular value. So filter tables can be used for this step, or you can use the computer package for this procedure. And then the third step is the scale and the conversion. The filter is scaled for the proper impedance level, and if desired it can be modified into the various topologies of high pass, band pass and band stop topologies. So the general block diagram involves filter specification, low pass prototype design, scaling and conversion, and then the implementation. However, in case of this design, the various types of scaling generally preferred are the impedance scaling and the frequency scaling. Thank you. This gets the complete analysis of the microwave filter. Thank you.